Hello, welcome back to AWS On Air. This is the last but one day. It's not over, so stay with us for a few more hours. I am Alex Casalboni. I'm a developer advocate from Italy. And today, for this session, I have Paul. Hi, Paul. How are you?
Hi, Alex. Hi, everyone.
So we are going to talk about this new functionality of Amazon Redshift, our data warehouse service. It's about performance optimization, automatic table performance optimization. But before we go there, Paul, maybe you can tell us in a few words what you do and what's your main priority in the Redshift team.
Yeah, thank you. Great to be here. My name is Paul Lapis. I'm a principal product manager for Amazon Redshift. And my primary area of focus is around all the self-tuning capabilities that Redshift is building to make it easier for users of any level of expertise to get started really easily and then get the fastest performance for Amazon Redshift quickly without having to manage any of the infrastructure and just have it work to scale up as you add more data and more users in a cost-effective way.
That's great. Thank you, Paul. So we have heard a lot about Amazon Redshift in the last couple of weeks. A lot of announcements went out last week during the leadership session from Raul. A lot of updates, a lot of new features, a lot of new integrations also with machine learning. So before we get into this specific new functionality, I wanted to ask, how do AWS customers get started with AWS today? What are the blockers? What are some of the challenges? And how can they get started quickly? Whether they are new to Redshift, whether they are new to even the data warehousing world, how can we help them there?
Yeah. Well, as you know, Amazon Redshift has, it's the most widely used cloud data warehouse in the world. And we help tens of thousands of customers, manage their analytics at scale. And our customers range from the largest companies in the world that you've heard of, all the way down to really, really tiny startups. And so, we as a service, we need to cater to a very wide range of users. And what we're seeing more and more in the market and the customers that we talk to is that data teams are investing more and more in data products, in sort of thinking about how to get insights from data and help their companies with data. Less about building reports and dashboards, which is still going on, but now they're actually delivering insights that they glean from their data to their digital products. They're providing data feeds to partners and customers. They're building bespoke analytical applications, to help drive the business and make critical business decisions. And so when they do that, what we see is that these data teams are like specializing in different parts of that entire stack. And so we have users that are not experts in DBA. They don't want to be experts in like infrastructure. They don't want to think about servers and things like that. They just want to launch a data warehouse and just start querying as fast as possible. And so what Amazon Redshift has been investing in over the past few years is in self-tuning capabilities across the areas of workload management. So ensuring that the most important workloads that you're running meet SLAs and that you can protect the system from users doing bad things. In addition to that, we've been working on query tuning, automatically. We'll talk about some of that today so that you can get faster queries without having to actually do anything. And then I think one of the things we'll talk about today is physical data design. It turns out that customers can store hundreds of billions of rows into tables in Amazon Redshift, which is crazy, and we have customers with 1 trillion rows. And so what really matters in a system like Redshift is that when you're storing data of that size, that the way that it's physically laid out on the system is really important to make queries fast. And up until today, customers have had to actually make manual decisions on how to lay out that data. And the layout of the data is really depends on the queries that run. And so when you have a lot of users running a lot of different queries, as an administrator, you might not really know what's the best way to lay out that data to optimize for joins and for filtering and things like that. So Redshift has also built machine learning based tools to solve that problem for customers, and that's one of the things we'll also give a demo on today. And so,
right, because no matter what size of data you're querying, you want it to be quick. I've seen so many situations in my career where you connected your data warehouse to your dashboards or your monitoring systems, and then you go, I want to see live metrics, and it's rolling for like 20 minutes because the query is running right now.
right.
So you want to avoid that as much as possible. But also there are many more ways to integrate data. You might have a data lake, either with Spectrum. There are a lot of options. So providing a way to automatically optimize those kind of queries definitely helps. So let's get into what we've actually launched. So what have we launched, and what kind of problem does it solve?
Yeah, so what we're launching is a feature called automatic table optimization. And what automatic table optimization, it's called ATO, is the acronym that we're using for it. And what it does is it is a feature that will speed up the performance of queries by automatically modifying how physical data is laid out and adapting that over time as queries change, as new users come onto the system, et cetera, et cetera. And the way that it works is so in Amazon Redshift, there's a concept, there's two ways that you can control how data is laid out. One is sorting. You can define a column that the data will be pre-sorted based on that column, so that when you are, say for example, say you have a table and each row has a timestamp, and you want to only say it's mobile events, customers that open up a mobile application, and what you want to do is you want to say, hey, show me all of the users that have opened up the mobile app over the past 24 hours. But say that this table has 10 years of data in it and 1 trillion rows in it. You want to have that data pre-sorted so that when the analyst asks that question, the system knows exactly where to go to get that data. And so what you do is you define that timestamp column as a sort key. And so the other thing that's so in addition to sort keys, there's also a concept of distribution. Amazon Redshift is a massively paralleled system where it scales horizontally by adding more nodes. And each node really doesn't have knowledge of the other nodes in the cluster. And so the way that data is physically laid out across all those nodes matters when you're joining data between two different tables, which is a really, really common pattern. So say you have, in the same mobile app example, say you have all the events from your mobile users, and so in another table you have the products that that they're buying. And maybe you want to bring all that together and say, well, show me all the products purchased in the past day. So you have to sort that first table, and then you have to join the first table to the second table. And that join operation can be very slow if Redshift has to sort of shuffle data around the cluster in order to actually get that result back. And so we have a concept of distribution key. And a distribution key will basically say, okay, for the distribution key, so you can pick one key per table. And if you pick a distribution key for a table, what Redshift does is it will put all of the rows with the same value on the same node, which means that if you're joining on a particular column, Redshift will not have to move data around in order to materialize that result back to you. And so basically all of this depends on how do we pick the right sort keys and distribution keys? It really matters what queries our customers are running. What are they looking for? What are they joining on? And in the past, customers had to figure that out manually. They'd have to look at SQL or do a bunch of work up front. What automatic table optimization does is it looks at the workload in real time, and it's constantly monitoring the queries that are running. It understands the data that's in the system, and it's able to come up with recommendations and optimizations to apply sort keys and disk keys to make performance faster. And the way that it works is that it, for distribution keys, for example, we will inspect all of the queries running on the system. Then we'll build a graph, and so we'll constantly score and try to predict the queries that are coming in the future based on what came in the past, and we'll come up with scores to actually test what different distribution keys might do to improve performance, and then we'll apply the key for you automatically if we determine that it'll actually speed things up for you. And so all of this is happening in the background automatically.
So it's kind of like having another additional teammate that knows exactly how to do this, right?
That's right. Our new robot friend, yes.
Yeah, in a way, because this is somehow also powered by machine learning.
Right.
Can we say that? Yeah.
That's right. That's right.
Cool.
Yeah.
And normally, I'm curious how, customers, you just said that customers were going to do that manually. Maybe they had to guess or to have very, very deep expertise in this field. So how would a database administrator go about taking care of this problem? It's something that you don't just do once and you're good forever. As you were saying, you want to keep doing it because workload changes, query changes. So it's something that you have to keep doing all the time.
Yeah. So what administrators would do before this feature is they would do one of two things. The first thing they could do is they could look at, periodically look at all the SQL statements that are running on the system. And you can imagine you have hundreds, or we have customers with thousands of analysts that are always running queries. You could look at all those queries, either build a tool to do that or look at them yourself, and you could say, okay, these are the keys that make sense for these queries, or I'm going to guess. But all that work has to be done up front, and then that work has to happen continuously as the users and data changes. The second thing that customers did is they looked at the Redshift Advisor. So the Redshift Advisor is a feature of Amazon Redshift that acts as a personalized DBA that provides actionable advice in order for you that sort of actions that you can take to improve cost performance of Amazon Redshift. At the Redshift Advisor last year, we launched recommendations for sort keys and disk keys. And so what customers used to do is they used to look at the Redshift Advisor, which is a manual process, and it would say, hey, go add these keys to these tables, and then they'd have to go in and execute the commands manually to apply those keys. And so automatic table optimization is actually using the recommendations from the advisor. And what we have done with this release is we're actually automating how they're being executed on the system in a way that minimizes and eliminates any impact on the actual cluster.
And I think that will help a lot of customers that maybe do not even have that long-term experience with doing this tuning manually, right? If you just need to store data and query data, and as a developer myself, I often have that need, and maybe I'll go for another option if the query is slow. So I think that will enable a lot of customers to get fast queries without having to spend years or months studying and optimizing. So my next question will be very practical. So how can customers go and start using this feature? I know you had also a slide to share with us. Do you wanna share that?
Well, actually, I can actually show a demo.
Okay, let's go for a demo then.
Yeah.
Let me enable your screen real quick. Here we go.
This feature, before we dive into the demo, this feature works for current customers and for new customers, and it's an opt-in model for existing customers. A lot of our customers really value the ability to have the automation, but then also if they're expert users and they want to actually and they know what they're doing, they want to get their hands dirty, they can still do that. So when we launched this feature for existing tables in Amazon Redshift, we didn't touch them, right? So for current tables, you have to go in and run a command to tell Redshift, hey, I want you to manage this table. And you do that by setting the sort key and the disk key to a new style called auto. For new customers, we're going to assume that you want us to manage it. Like, to your point, Alex, you're like, I don't want to deal with it. I just want to write code and get insights. So what we did is we changed the default. When you create a table, Unless you tell us otherwise, we will assume that you want us to manage it, and we'll set a distribution key of auto by default. And so let me just show a quick DDL of what that looks like. So in this quick demo I've got set up is what we're going to do is just create two tables. We're going to show how you can run some joins and some queries on them, and then actually we're going to measure the results, and then also show how you can see what the automation is doing in the background. So the two tables are, one is called part, and the other table is called line item. And so as you can see, when we create this table, we're not picking a sort key or a disk key. Now, what customers would do in the past is they would actually have to add some text here that said sort key equals, say, one of these column names, or disk key equals one of these column names. Because we haven't done that, we have now essentially authorized Redshift to manage these tables for us. Okay. Now, I want to actually touch on another cool thing that Redshift does that's automatic to you. It also will manage the compression encodings. We didn't talk about this a lot, but compression, the way that data is compressed on disk matters for two reasons. One is it takes up less space, and then number two is queries that access that data are faster because they have to read less from disk. So Amazon Redshift will determine the optimal compression encoding for a particular column, based on the actual data in the system. And the way that it works is that when you copy data into Amazon Redshift using a copy command, it will sample the first 100,000 values of that table, and it will automatically say, hey, I think AZ64 encoding is optimal for that particular table. This query that we just ran is that we're selecting from a table, an internal table called PG table def, and that will tell us the encodings for each column. And so what we see is that Redshift picked AZ64 for a bunch of these columns, and it picked LZO for a few other columns. And Redshift is continuing to innovate on new compression technologies, and so this is a cool feature that just sort of manages that for you without you having to think about it. Cool. So let's now take a look at these two tables that we copied in, the part and the line item tables. Let's go ahead and actually confirm the sort key and distribution key that Redshift picked for those tables. There's a table, another system table inside of Redshift called SVB table info. And when we query that table, what it tells us is the disk style, the existing disk style and sort key for these tables. And both are now set to auto. Now, the value in parentheses is the actual distribution style and sort key of the table that Amazon Redshift has picked. As you can see, for this style, it has selected a distribution style of even. Now, Redshift has three types of distribution styles: all, even, and key. All and even are going to be the distribution styles that your table that new tables get. All means that Redshift is copying the table across all the nodes, and this is the best distribution style for speed, because basically any node that Redshift accesses is going to have an entire copy of that data. The downside of all distribution is that it increases the amount of storage utilization of that table by the number of nodes that you have. And so for big tables, it's a bad idea. So Redshift will automatically pick all or even based on the size of the table. If this table were small, it would have picked all here, and then it'll automatically change the distribution style to even as the size of the table grows. And then the sort key, there's no sort key. When we create a new table in Amazon Redshift, the default is that there's no sort key at all. And so that's, now we have these two tables. Let's sort of take a look at the queries that we want to run. So there's two queries here. The first query is joining and doing a predicate. It's doing a where clause. So it is going to be joining on those two tables on the part key columns. and it's also doing a filter on the ship date column on the line item table. And then the second query is just simpler. It's just a select statement, and it is ordering. It's doing aware. It's doing a filter on the ship date column as well. So Alex, a pop quiz for you. What do you think the distribution keys should be for these tables?
That's a good question. I don't know. You tell me that.
Yeah, it should be the part key column because we're joining on that. So just a it's about how long it takes. I think this is a question that we get a lot. So we need to feed examples into our machine learning algorithms, and so the examples that those algorithms need is the actual query itself, and then the metrics and the statistics that query provided, like how long did it take, how much data did it have to shuffle around nodes. And so the algorithm needs a bunch of examples before it can have confidence in making an optimization recommendation. So there's no rule of thumb, but you have to run a couple dozen queries in order for it to get enough confidence. And if you have a lot of different users on the system that are doing a bunch of things, then that might take a little bit longer. As a rule of thumb for a new table, if you launch a cluster, you launch a table, and you start running queries on it, the system should apply keys if it determines that doing so will improve performance within about 3 hours up to 12 hours, depending on the number of queries that you're running. So it's pretty quick, but it's the thing to remember as well is it's only going to make changes if we have high confidence that doing so will change the result. We also have customers that have asked for a way to prioritize user queries. So not all users have the same priority, Alex. Maybe your queries should have the highest priority in the system because you're doing, you're a data scientist and you're doing exploratory analysis, and fast queries for you is important because it means that you can get through your workday faster and accomplish more things. Whereas maybe some of our ETL jobs that are just sort of crunching data in the background, they can run as lower priority. But customers have asked us to to provide hints to the algorithm to indicate whose optimizations we should prioritize if we're forced to make a decision like that, and that's something that we'll work on also next year. So for this demo, what we've done in the background is we ran 500 of these queries just really quickly on the system. Now let's take a look at the actual optimization recommendations. There's a table in Redshift now. It's a new table. It's called SVV_alter_ table recommendations. And when you query this table, it will show the backlog of optimizations that Redshift will apply on the system. And in this case, so there's a few columns here. One is the type, the style or sort key. We can also have the table ID that we're going to be optimizing. The actual DDL is also here. This is the exact DDL that is going to be executed on the system. And then finally, there's a column called auto eligible. One of the things I mentioned earlier was that not all tables are defined with the auto style. And so whether or not they are, we'll still come up with recommendations for them and optimizations for them. If there's a true in this column, you can expect that Redshift will apply the optimization automatically. If it's false, then we won't do anything, but the user can always go in and run the command themselves, which is what we recommend. And so let's see what it did. So the first optimization is it wants us to add a disk style, a disk key of part key on the part table, and that makes sense because we were joining on that. The second optimization that it wants us to do is to add the L part key column on the line item table, and that also makes sense. If you recall, Alex, those were the two columns that we were joining on. So it was to determine that join was happening, and that's optimal. And then the final one was a sort key on L ship date. So we had on the queries that we ran, we were we had a where clause on this column on both queries. And so Redshift said, hey, I should sort that table by L ship date so that that where clause will be faster. And so, boom, all this happens automatically without you having to do anything. And then, there's also a table in Redshift called SVL Auto Worker Action. And what this one does is it just gives you a log. Our customers, almost everyone asks, hey, can you just show me a history of what the system is doing so I can see what changes are being made. And so we added an actions table that provides just a historical record of all the optimizations as well as the previous state. And so as we do work, we'll give you a way to audit what's going on. So some time has passed. Redshift has applied these optimizations to our tables. Let's query the SVB table info table again to confirm that that Redshift in fact did actually apply those keys. So sure enough, the disk styles on both tables were changed. You can see here that the disk style is key and the sort key is set to L ship date on this table. And so this was done all automatically. Now, what I wanted to share as well is the performance, the before and after. So when we ran these queries, the way that we measured performance is we added a label to them. We added a label of before and after. And there's a table in Redshift called STL query that lets you sort of look at the elapsed time of queries. Let's see if I can scroll down here. So we're doing a query on STL query in order to look at the elapsed time of the queries before and after the optimizations were applied. And I actually have a PowerPoint that I can share where I can actually visualize those results for you. So it's pretty impressive. So on the first query, the one where we have the join, the latency, this is an average of about 500 runs, went from a little bit over 300 milliseconds to under that. So we saw about a 9% improvement by adding a join key, a distribution key. On the second query that was just doing a select with the where by date, we actually saw a 34% increase. So it went from a little under 500 milliseconds to a little over 300 milliseconds because Redshift was able to pre-sort that data before we queried. And in fact, customers like ZS Associates in their own environments have reported back to us that they've seen improvements of 25% of overall.
That's pretty cool.
Yeah.
That's pretty cool.
Yeah. Yeah.
So Paul, thank you for your demo. We've got to wrap up in about a minute. So what I really wanted to ask you, if you can share some numbers real quick, is also about pricing, right? So it's super easy to get started. You don't need to learn to know almost anything about distribution keys and sort keys. So how about pricing?
So it's free.
Nice. I like that answer.
It comes with Redshift. Yeah. We made a decision early on that, and this is part of Amazon's way. We work aggressively to decrease cost performance. We pride ourselves on having the best cost performance of any data warehouse in the world. And so we're always thinking about how to actually let our customers get more bang for their buck. And so this is just included for free with any new Redshift cluster. Yeah.
Love it. Thank you so much, Paul. So you've told us a lot about all the different techniques and things that Redshift does for you to recommend improvements, and also what it does automatically for you. So thank you so much for your time, Paul. And I'll leave you guys another minute or so to have a break, and then we'll meet you in a couple of minutes for the next AWS On Air session. Thank you so much, Paul. Have a great day.
Thank you, Alex.